complex number. Let's talk about this. Where we see complex number, what are these complex number, how they come into existence, and all those good stuff here. So, for example, if you try to find something like this, square root of -1. Look here. If you try to find the square root of a number, the square root of -1. If you try that in your calculator may say undefined or something like that. But in fact, you don't have a real value for the square root of -1. We define this as I. We call it I. And that I is the imaginary unit. Okay, that is the imaginary unit. That means if you square this on both sides, for example, if you square this, let me rewrite this and square it. -1, square root of -1 is I. Now, if I square this on both sides, what I get is, if you look at the left side, square and square root, they are the opposite operation. They undo each other. They cancel each other. And once they cancel each other, what we get is -1. -1 equal to I squared. So I squared is -1. That means if you square the imaginary unit, it's going to be -1. So we get two important concepts here, two important formulas here to get started with the complex number, with the imaginary unit, okay? Square root of a -1 is I. That is basically the definition. We cannot find the real value of the square root of a negative number, so we call it an imaginary number. And this is for unit or 1. 1 is also called unit. So it is a square root of negative unit. That's why it is called the imaginary unit. And when you square it on both sides, you get I squared equal to -1. So this will help us solve something like this. Say, for example, you want to find the square root of, let's say, -36. If you want to find the square root of -36, later on, when you're used to, you'll be able to write it easily. But for now, I want to show you the steps. -36 is same as -1 times 36. -1 times 36. And then you can find the square root of each of these. The square root of -1, we already defined here. Square root of -1 is I. I multiplied with square root of 36. You know this. Square root of a positive number. What number when you square is 36?
6.
6. That's right. So square root of 36 is a 6. So that is 6 times I, or 6I. So basically, you know that square root of 36 would be 6, but because you have a negative inside the square root, we have I there. Okay? So square root of a -36 is 6I. We are going to look at a couple of examples here. This number that is with I here, you can see 6 times I. This is called a pure imaginary number. Pure imaginary number. It's called pure imaginary number because it is only with I. There is nothing added or subtracted to that. It is just with I. If it is just with I, then we call it pure imaginary number. So this is a pure imaginary number. It's not yet complex number. Maybe it's a part of a complex number. That's true, but it's not a complete complex number. It has only the imaginary part. So we call it pure imaginary number. Okay, let's look at a few more examples. But before we dive into the examples, any questions so far?
So the -1 is always I.
Right, the square root of -1 is always I.
Oh, the
Square root of
square root of
-1,
-1.
right. The square root of -1 is a I. That is something to remember. Yeah. Okay, let's move on to the example then. Okay, here we go. So I have a couple of example problems here. First one is square root of negative 16. So let's see how we can do it, just like the previous example we did. Square root of negative 16, it is negative 1 times 16. And you know the square root of negative 1. What is the square root of negative 1?
I.
I, correct. And what is the square root of 16?
4.
4. Very good. So 4 times I is how much?
4I.
4I. We got that. So square root of negative 16 is a 4I. Okay. So you could have done directly. If you do it directly, it's totally fine. It's a negative number, so you get an I at the end, and the square root of 16 is a 4. Now let's look at this one. Square root of negative 8. Let me do it a little differently this time. Okay. Negative 8 is same as negative 4 times 2. Negative 4 times 2 is negative 8. Anybody in the class can answer this question? What is the square root of negative 4?
2.
2i.
2i, right? That's a negative. So 2i, very good. 2i. And what is the square root of this 2? We cannot find the exact square root, right?
Yes.
So we write that as root 2. Okay, so that is 2i root 2. Because we cannot find the exact square root of 2, so we write it like that. Okay. Now, what is this one? I to the third. That's kind of interesting. See, I to the third power. When we say I to the third power, is it same as I to the 2 times I? Is 2 plus 1, 3? Right?
Yes.
We split that I cubed into two parts, I squared and 1. The reason I wrote I squared is I know the value of I squared. How much is I squared?
-1.
Negative 1. That's right. Negative 1 times I. How much is negative 1 times I?
Negative I.
Negative I. That's right. Negative 1I, which is simply written as negative I. Okay. Next one is also interesting. What is negative squared? Let me write like that. Negative I squared is same as negative I times negative I. Yes or no? Square means you multiply the quantity with itself. So negative I squared means negative I times negative I. And you know that when you multiply a negative with a negative, that's positive. Okay. And then I times I is I squared. So you don't have to write positive in front. You can simply write I squared. But what is I squared equal to?
Negative I.
I squared is a negative 1. So we got it. Okay. So those are the solution to this problem. If you have any question on this, let me know. This is very, very simple. And you can see that these first three answer, 1, 2, 3, they involve I. So these are the pure imaginary numbers. First, second, third. The answer we got there, these answers are pure imaginary numbers. But the last one here, it does not have I in it. If there is no I on the number, this is a real number. This is a real number. First three are imaginary numbers, but the last one is a real number. So in these two, C and D, we calculated the power of I to the third, negative I to the 2. Let's look at some other power of I, how we can evaluate the power of I. Look, one thing here for the odd power, I split into even power and I. 2 and 1, that makes a total of 3. So that concept is always true when you want to evaluate the odd power of I. Let's see what it means in the next example. But before I move to next example, any question on this one? Okay. No question. Here we go. Next example, still computing the power of I. First one, I to the 9th power. I can write that as I to the 8th power multiplied to I. So if it is a odd power, I can write an even power and then 1i at the end. So 8 plus 1, that's a total of 9. Because this one, the first one, I can simplify easily. How? I to the 8 is same as I squared to the 4th power. At the end, we are multiplying by I. Because 2 times 4 is 8. And also, I know the value of this quantity inside the parenthesis. What is the value of the quantity inside the parenthesis?
-1.
Negative 1. Right, because I squared is a negative 1. So you can plug in there. That's a negative 1 to the 4th power multiplied to I. And when you raise a negative number to the even power, it's going to be positive. So our answer is positive. If it was odd power, it will be negative. In this case, we have an even power. So answer is positive. And 1 to the 4, if you multiply 1 with itself 4 times, 1 times 1 times 1 times 1, that is still a 1. Multiplied with that I. And 1 times I is a I. That means I to the 9th power is a I. So in the exercise later on, you are going to see some of the problems like this where you need to evaluate the power of I. It can be odd power like that, or it can be even power like this one here. So let's see how we can do I to the 28. That should be very easy. Even powers are very easy. 28 is same as I squared to the power 14. 2 times 14 is 28. That's why. And we know the value inside the parenthesis. What is that again? I squared is how much?
-1.
-1. Very good. To the 14th power. And as I said before, negative raised to the even power is a positive number. So my final answer is positive. And I'm multiplying 1 with itself 14 times. 1 times 1 times 1. We keep going, but that's always 1. So I raised to 28 is a 1. That's even power. The next one you are seeing here is also the even power, but let's see what happened. So I can write that as I to the 102 can be written as I squared to the 51 power. Because 2 times 51 is 102. 2 times 51 is 102. Now, we know this quantity inside the parenthesis, I squared. Just like here I have I squared. Here I have I squared. See the pattern there. I squared, that's a -1. -1 raised to the power 51. And that is equal to, you can see, negative raised to the odd power this time. Here it was -1 raised to even power. Here it was -1 raised to even power. The answer was positive. But here we have -1 raised to odd power. Answer will be negative. And then 1 raised to 51, 1 raised to any power is 1. So you can see I to the 28 is 1 and I to the 102 is -1. So always remember, when you're calculating the even power of I, your answer is either 1 or -1. Similarly, if you calculate the odd power, in that case, your answer will be either positive I or sometimes negative I, depending on what coefficient will be there. I mean, what exponent will be there? Okay, that is about the power of I.
I have a question.
Yeah.
Okay, in order to break down, I'm on number C, to break down I to 102nd, you divided that by 2, and the
Right.
remainder was 51.
That it goes 51 times. Yeah.
Okay.
Yeah.
And
Because
so, oh,
the reason is I want the I squared inside. That's why I divided by 2 everywhere. Okay.
I see.
If any one of you have any other question, feel free to ask. Okay. Okay. Now let's move on. We are working on little more, not challenging, but beautiful question. Okay. You can see here we have simplifying the complex expression. Now see, look at all these numbers here, everybody. If you look at the numbers inside the parenthesis on all these are not just pure imaginary number. Instead, you can see that each of those numbers are in the form A plus BI. It can be plus or minus. So first number is without I, second number has a I. Look here, first number is without I, second number has a I. First number in the second parenthesis is without I, the second number is with I. If you see that combination, then these type of number, they are called complex numbers. These are called complex numbers. You are going to see in the later part of today's lecture, when you start working on quadratic equation, when you solve quadratic equation, we get some of the answers as complex numbers like this. Okay, so that's why we are first working with these complex numbers to get the proper understanding of how these complex numbers work. Okay, here we have a couple of problems to solve. The first one is basically, the first one is the addition of complex numbers. See, there's one complex number, there is the other complex number. We are adding those two complex numbers, plus in the middle. So we have 4 plus 3i. The first one is 4 plus 3i. The second one, here is a plus sign. So if I distribute that plus sign, positive times a negative, that's a negative. So minus 5. And if I distribute there, positive times positive is still positive, 7i. Right? Basically, I distribute that sign inside. Positive times negative, negative. Positive times positive, a positive. Now combine the like terms. So what I mean by that, combine the like terms means, see, here is a number without I, here is a number without I. We need to combine those two. So that is 4 minus 5. 4 minus 5 is a negative 1. And then the second part, we have 3i plus 7i. How much is 3i plus 7i? 3 plus 7 is?
10i.
10, that's right. So 10i. Very good. So we added the complex number there. So in the first one, it was the addition. Okay, the first one is the addition of complex number. Now let's look at B. In B, look at this carefully. We have one complex number here. The first one is one complex number, which is in the form A and BI. So that's a complex number. And here in the second parenthesis, we have a second complex number. But in the middle, we have a minus. If we have a minus sign in the middle, meaning of that is it addition or what is it?
Subtraction.
Subtraction. So in this one, we are looking at subtraction of complex numbers. Subtraction. But the idea is same. You distribute that sign. So we have negative 2 plus 3i, negative 2 plus 3i, then distribute that negative sign. Negative times negative is how much?
That's positive
Positive,
5.
right? That's right. Negative and negative is positive, then 5. Very good. And the negative and positive there. Negative and positive is?
Negative.
Negative. And we have a 3i. Now we just need to combine the like terms. So here we have a negative 2. Look at that. Negative 2 plus 5. These two are without I, so we can combine. Negative 2 plus 5, or in other words, 5 minus 2, right?
3.
What is that equal to? 3. Very good.
3.
Yes. And then you can see in this one, there is a 3i and minus 3i. How much is 3i minus 3i?
0.
0i. So I don't have to write that 0, right? Because by adding 0, it doesn't change. So basically those two cancel. Positive 3i, negative 3i, they onto each other. The result will be 0. So it is simply 3. So we did the addition of complex number. We did the subtraction of complex number. What do you think about this third one? What do you notice? We have 3 plus 2i in one parenthesis, negative 2 plus 3i in the second parenthesis. Let me write here. 3 plus 2i and negative 2 plus 3i in two parentheses. There is no sign in the middle. What is the meaning of that?
Multiplication.
Multiplication. That's right. We did the addition, subtraction. So third one is basically multiplication. And you know from your algebra, if we have two quantities in one parenthesis multiplied to two quantity in the other parenthesis, we use the FOIL method to multiply. Is that right?
That's correct.
Okay. So let's multiply. So we multiply this 3 with 2. I'm going to show with the arrow. So feel free to add that in your notes also. Yes, negative 6. And then that 3 will multiply that one. So 3, it's a positive. So plus 3 times 3i. How much is 3 times 3i?
9.
9i. Very good. 9i. Now we multiply here. Look at that. We are done multiplying with 3. Now we have to multiply with 2i. 2i times negative 2. How much is 2i times negative 2?
Positive 4i.
We have a plus and a minus. When you multiply positive and negative, that's a negative. Okay, we are multiplying a positive with a negative, so that's a negative. And 2i times 2 is a 4i. There we go. And then let's multiply the last one. 2i with 3i. Both are positive. Positive multiplied to positive is positive. 2 times 3 is a 6. And then I times I is how much? I times I?
I squared.
Where?
I squared. That's right. I squared. Now, let's combine the like terms. Negative 6. We can combine these two in the middle. 9i, positive 9i. So 9i minus 4i. How much is 9 minus 4?
5.
5. So that's a 5i. 5i. And then plus 6 times. What is the value of I squared? We already know what is I squared in the beginning.
Negative 1.
Negative 1. So I squared is negative 1. Let me write here. Note that I squared is a negative 1. Okay. Note that I squared is a negative 1. So now let's rewrite this. We have a negative 6 plus 5i. Then 6 times negative 1, that's a negative 6. So when you combine, let's see what we get. So we have a negative 6 and a negative 6. Negative 6 and negative 6 is how much?
Negative 12.
negative 12, and then we have plus 5i. Plus 5i. Okay, we did the addition, we did the subtraction, we did the multiplication. Are we good so far?
Yes.
Okay, wonderful. Let's do one more. There is a D there. Okay, in D, look at this. We have 2 minus 3i quantity squared. Meaning of that is 2 minus 3i. 2 minus 3i is multiplied to itself, right? Quantity squared means 2 minus 3i times 2 minus 3i. That is the meaning of that. 2 minus 3i quantity squared is 2 minus 3i times 2 minus 3i. So as soon as I write like this, you can see that it looks very similar to C. Okay, it looks very similar to C. Two quantities are multiplying there. So use that FOIL method. So we multiply 2 times 2. That's a 4. 2 times negative 3i. That's a negative 6i. And then 3i, negative 3i times 2. So that's a negative 6i again. And at the end, if I multiply these two, negative multiplied to negative is positive. 3 times 3, 9. I times I squared. Then you start plugging in values and combining like terms. So when you combine the like terms there, negative 6i, negative 12i, plus 9 times I squared is negative 1. So we plug in the value of I squared, just like here. I squared is a negative 1. 4 minus 12i, and then positive 9 times negative 1. 9 times 1 is 9, but positive and negative will make negative, so minus 9. And after that, you can combine the like terms here one more time. 4 minus 9. 4 minus 9 is a negative 5. Negative 5 minus 12i. Okay. So before we move on, let's look at these answers. 1, 2, 3, 4 answers we get. In the first answer, you can see that there is a number without I first, just like this one, A. And the second one is number with I. Number without I plus or minus a number with I. That means this is a complex number. Our first answer is a complex number. Okay, that is a complex number because it is in the form A and BI. We have to write complex number in the form A and BI. This number, there is no I there. That means this is a real number. Answer in the second problem is a real number. Third one here, you can see a number without I plus a number with I. So that is a complex number. Complex number. So what can you say about this last one? Is that a real number, complex number? What is that?
I would say complex.
That's right. It has a real part and that imaginary part. So that is a complex number. Complex number. So A and B is addition, C and D, they are, A is addition, B is subtraction. We can say addition and subtraction, right? So they are just the opposite operation, are basically the same operation, however you want to call it. But C and D, they are multiplication. So after we do addition, subtraction, multiplication, what do we do next?
Division.
Sure, we are going to do some division of complex number, okay? But before we move on to division, is there any question on this slide? We did quite a bit of work there. Okay. If you have no question there, let's move on then. Okay. Division of complex number. So the first one, if we look at the first one, A, let's begin with A. We have 2 plus 3i over 3 minus I. So when you're dividing a complex number, so I'm going to write a quick note for you. If we are dividing a complex number, what you need to do is you multiply both numerator and denominator, because when you're dividing, look here, there is one complex number in the numerator, one complex number in the denominator. So when you perform that division, what you actually need to do is you need to multiply both numerator and denominator by the conjugate of denominator. We have to multiply both numerator and denominator by the conjugate of the denominator. That will be the starting point. So that means here what we are going to do is, look here, we are going to multiply the numerator by something. We are going to multiply the denominator by something. That something is the conjugate. That something is the conjugate of denominator. Conjugate means, listen carefully, conjugate means you change this sign in the middle. The sign with the I should be changed. So that is, here we have 3 minus I. The conjugate of that will be 3 plus I. Just change the sign that is there with I. So 3 minus I becomes 3 plus I. So you multiply both numerator and denominator. So in the numerator also, you are going to multiply by 3 plus I. That is your first step. Remember this sentence that I wrote here. Make sure you write this sentence in your notebook, highlight it, because when you're doing the exercise, you might need that. You need to multiply both numerator and denominator by the conjugate of the denominator. Okay, are we good here? Now let's do that multiplication. See, we are multiplying two fractions. When you multiply the fraction, you multiply numerator with numerator. So we already know multiplying complex number. We FOIL in the numerator. So we do this. Look at the screen carefully now. 2 times 3, that is a 6. And then 2 times I, that's a 2i. Because first we multiply by 2. 2 times 3, 6. 2 times I, 2i. Then you multiply by 3i. 3i times 3, that is 9i. And then 3i times I, that is 3i squared. We multiply the numerator. Similarly, you have to multiply the denominator. 3 times 3, that's a 9. And then 3 times I, 3 times positive I, that's positive 3i. Then let's multiply by this negative I times 3, negative 3i. And then negative I times positive I, that is negative I squared. Okay, now let's keep going here. We have a 6. Let me simplify the numerator. We have a 6, then plus, you can see we have a 2i plus 9i. 2 plus 9 is 11. So 11i plus 3 times I squared is negative 1. So in place of I squared, you can write negative 1. And in the denominator, do the same thing. We have a 9. And then in the middle, look here, we have a 3i minus 3i. 3i minus 3i is 0 because 3 minus 3 is 0. So they just get canceled. And then I have a minus sign. This minus sign, by the way, I'm writing this minus sign here. Now I have a I squared. I squared itself is a -1. This negative sign first, and then I squared, which is also -1. You have to be very, very careful with those little negative sign. Okay, I'm going to pause here for a little bit so you can finish up your writing, or you have question, you can ask me. Make sure if you're asking question, you are unmuted. So
Oh, I was asking when you're multiplying the numerator, is it similar to multiplying using the FOIL method?
right, the FOIL method,
Okay.
exactly. Numerator with numerator FOIL method, denominator with denominator FOIL method. Yeah.
Okay. So just multiply straight across.
Right, because when you're multiplying fractions, you multiply straight across. Yes, you got it. Okay. So that is the power of turning on video. You are talking, but you are muted, but I see it, right?
Yeah.
Okay. Now, in the numerator, you can see we have a 6 plus 11i, and then we have positive 3 times -1. That's a -3. And in the denominator, we have a 9. And then we have negative times negative, that's +1. So what I'm getting is, you can see 6 minus 3, that's a 3, plus 11i over 9 plus 1 is 10. So we get 3 plus 11i over 10. That is my answer, but not the final answer. Because the way we write the complex number, what we said is, we write the complex number in this form. It should be a plus bi form, okay? So for this one, what we can do is, the denominator, now look at the screen carefully, everybody. The denominator for these 3, this is a common denominator. Denominator for 3 is 10. So I can write that as 3 over 10. Then plus, denominator for this 11 is also 10. So I can write 11 over 10 and then that I. So if I separate the denominator like that, if I write the denominator for both the numbers, then you can see that our final answer is in the form A, then plus BI. That is a standard complex number. That is the standard form. You have to write your final answer in a standard form. Okay, I'm going to work on that B in a little bit. First, I'm going to work on C because it is easy and the room that is available here will be enough for me. So I'm going to work on C first, okay? But before I work on C, is there any question? Okay, look like there is no question, which is good. Okay, this one, 1 over I. You can see that there is I in the denominator. So let's follow the rule. What I said is, if you are dividing by a complex number or imaginary number with I, we multiply by the conjugate in both numerator and denominator. And I told you, conjugate means you change the sign of this I. This is a positive I. So multiply both numerator and denominator by negative I. Hold on, what did I do? Okay, there we go. We multiply both numerator and denominator
So
by
are we
negative
doing
I.
B? Are we doing B last?
Yes, we'll do B at the end. We are doing C first. Because I need a little more space, so I want to do that in next slide. So one more time, what I did here is the same concept. I'm dividing by an imaginary number, which is also the complex number. What I need to do is I need to multiply both numerator and denominator by the conjugate, right? I have to divide. So I have to multiply both numerator and denominator by the conjugate of the denominator. Conjugate of I is a negative I. Now let's perform that calculation here. In the numerator, I have 1 times negative I. That is negative 1I or simply negative I. And in the denominator, look at that. We have I times negative I. Positive and negative, when you multiply, that's a negative. And then I times I is I squared. Now look at
I
the
see.
magic. So we have a negative I over that minus sign in the denominator first. This sign. Now write the value of I squared. How much is I squared?
-1.
That's also negative 1. So what I get is, if I simplify that, I get negative I divided by, in the denominator, what I have is negative 1 times negative. Negative times negative is positive. Like that. So I get negative I divided by 1. When you divide by 1, the value will not change. That means it is simply negative I. Right? The value will not change. It is simply I. Negative I divided by 1. Positive divided by negative. Negative. When you divide by 1, the value will not change. It is simply I. Now see, this answer, the first answer has A and BI form. So definitely that is a complex number. Complex number. And you can see that this one involved only I. I told you, if the number involved only I, that is a pure imaginary number. Pure imaginary number. But remember, pure imaginary number is also a complex number. This is also a complex number. That means any number involving I is the complex number. This is complex number, this is complex number. But if the real part is missing, if the number without I is missing, then it is pure imaginary number. Okay, in complex number, you have both real and imaginary number. Okay, let's do that B now. We'll do that B here. Okay, anybody in the class, what is the meaning of that -1 power? Anybody has an idea what is the meaning of -1? Yes.
That means it's we can write it as 1 over 4 negative 3i.
That's right. So meaning of power -1 is a reciprocal. So we can write that as 1 over 4 minus 3i. So you can see that we are dividing by a complex number. 1 divided by a complex number. 4 minus 3i is a complex number. And I told you, when you're dividing by a complex number, multiply by the conjugate. Conjugate means you change the sign that is there with the I. So you change this negative to positive. So we multiply by 4 plus 3i. 4 plus 3i. And let's see what we get. We already know that we multiply straight across. Numerator with numerator, denominator with denominator, right?
So it's 4 plus 3i.
Right, the numerator is multiplied by 1, so that's 4 plus 3i. And in the denominator, we FOIL. So that means we do 4 times 4. That is how much?
16.
16. So we do 4 times 3i now. So 4 times 3i is a 12i. And now we multiply by -3i. -3i times 4, that is -12i. And then -3i and positive. Negative and positive, that's a negative. So you have a 3i times 3i. 3 times 3, 9. I times I squared. Now let's simplify the denominator, we have a 16. And then 12i minus 12i.
They
That's
cancel
a
out.
0. They cancel each other. That's right. And we have minus 9 times, what is I squared?
-1.
I squared is -1. There we go. So that is equal to 4 plus 3i over 16. And then we have -9 multiplied to -1. Negative times negative positive. 9 times 1 is 9. So what I'm getting is, let me write here, I get 4 plus 3i over, in the denominator, how much is 16 plus 9?
25.
25, very good. Now let me write that in standard form. That is, this 4 has a denominator of 25, so I can write 4 over 25. 4 over 25, and then plus this 3i has a denominator of 25, so I can write 3 over 25i. So that it is in the form a plus bi, the standard complex number form. Okay, so that is about dividing complex number. Always remember, when you're dividing by a complex number, okay, what you have to do is you need to multiply. When you're dividing by a complex number, the rule is you have to multiply both numerator and denominator by the conjugate of the denominator. And when you multiply, you use the regular FOIL method. Wherever you see I squared, plug in -1 and simplify. And when you write your final answer, try to write it in the form a and bi, meaning you separate the denominator so it looks like a and bi form. That is the standard form for the complex number. Okay, if you have any question on that, let me know. If not, we are going to look at 2 more problems that involve the imaginary unit I or the complex number. So you are going to see all this type of problem when you do the homework, okay? When you do the homework, you are going to see each of these type of problem. You'll see the addition problem, you'll see the multiplication problem, you'll see the division problem, you'll see the radical we simplified in first example. You're going to see all those. Okay, the last one from this unit. Simplifying this expression. So let's look at A. So in A, what I have is, you can see I have 2 minus, let's think about this one, square root of -3. Let me do some side work here. Side work. To understand that square root of -3. -3 is same as -1 times 3. Right? -3 is same as -1 times 3. Square root of 3 is not a perfect number. It's just square root of 3. But I know the square root of -1. What is the square root of -1?
+1.
That's I,
I.
right? So that means this one they have written here is 2 minus square root of 3. Square root of 3 is I root 3, okay? That is I root 3 and then quantity squared. So what they are trying to tell us is, by writing this one, they are saying that you do this operation of complex number. Power 2 or square means you write it twice. 2 minus I root 3 multiplied to 2 minus I root 3. So that is basic multiplication, right? Multiplication of complex numbers. So let's do the multiplication. If you multiply 2 with 2, 2 times 2, that's a 4. Then if I multiply 2 with this one, see, I did 2 times 2 first. If I multiply 2 with that, what I'm getting is minus 2I square root of 3. I'm multiplying that quantity by 2. So 2I square root of 3. And then if I multiply here again, see, we are doing the FOIL. So that is also 2 times that quantity. It's a negative. One is positive, other one is negative. So negative 2 times that quantity. So that is 2I square root of 3. And then at the end, if I multiply this one with this one, the last one, negative multiply to negative, that's a positive. Look carefully here. Sometimes this is confusing. I times I, that is I squared. And then square root of 3 times square root of 3. Square root
9.
of 3 is squared. Right? Square root of 3 times square root of 3. Writing it twice means that is a square. 3 squared is 9. But this is square root of 3, right? So square root
Yeah.
of 3 times square root of 3 is square root of 3 squared. Okay, so we have a 4. These two you can combine, the middle two. 2I square root of 3, 2I square root of 3. If you look at that, we have a total of 4. 2 and 2 is 4I square root of 3. Right? 2 and 2 will make a total of 4. So 4I square root of 3. Then plus, write down the value of I squared. I squared is negative 1. Okay, this I squared is a negative 1. And then, one more time, please look at the screen. We have square root of 3 squared. There, what happened is square and square root, they cancel each other. So we are left with 3 only. 3. Because square and square root, they are the opposite operation. When the opposite operation occurs together, they undo each other, and we are just left with that quantity. Okay?
So that's how
now,
you get rid. Oh.
Yeah, that's how we get rid of that root. Yes.
Okay, I get it. Now I see.
Yeah. Okay, so we have 4 minus 4I root 3, 1 times 3, but negative is there, so minus 3. So what we end up getting is, you can see here, it's 4 minus 3. 4 minus 3 is 1, minus 4I root 3. So although they have given the question in this format, there is no I in the question. In fact, I was hidden there because square root of negative 3 is in fact I root 3. I was already there. So that's why that is a complex number squared, a complex number multiplied with itself. And then when you do that multiplication, we get a complex number also. Okay. Now let's look at the last one. Last one has square root of 4 over square root of negative 4. This is quite simple, but not that simple though, okay? Square root of 4, you know it. What is the square root of 4? Everybody in the class, what is the square root of 4?
2.
2, very good. And what is the square root of negative 4?
I, 2,
2i.
2I.
2i. So you can see we are dividing by a complex number, right? 2i, number with I. So if you are dividing by a complex number, you have to multiply both numerator and denominator by conjugate of that. Multiply both numerator and denominator by negative 2i. Conjugate means you change the sign that is associated with that I. That is a positive 2i, so make it negative 2i. Then multiply numerator with numerator. 2 times negative 2, that's negative 4i in the numerator. Over, look at the denominator. We are multiplying positive and negative. If we
It's a
multiply
negative.
positive and negative, that's a negative. How much is 2 times 2?
4. Negative 4
And then I times I?
squared. I
I
squared.
squared. Can I cancel those 4? 4 divided by 4 is 1, right?
Yes.
I can quickly cancel that. Then let's see what I get. Negative I in the numerator There is already a minus sign there, this minus sign from the denominator. And what is the value of I squared?
-1.
-1, that's right. So we get, let me write here, negative I divided by negative of negative is a positive. So we are dividing by +1. When you divide by 1, the value does not change. Whatever is there, we write it down, negative I.